I'm creating this video because I was checking the other day my YouTube channel and I don't have any video explaining this topic, which is separation of mixtures. I'm doing this so in case that you have any question, you can go back or refer to this video. But remember that you're not learning anything new. This is not chemistry. This is physical science review. First, I would like to start with the classification of mixtures. Remember, pure substance can be separated by chemical means, but mixtures, they're gonna be able to be separated. The different components that you have in a mixture, you're gonna be able to separate all of them using physical means. And when I'm talking about physical means, I'm referring to the physical properties. So chemical reactions, they don't have to be involved. But before, I would like to refresh your knowledge about classification of mixtures. Mixtures, they can be divided into homogeneous mixtures and heterogeneous mixtures. What is the difference between solutions and heterogeneous mixtures? That when you look at a solution, you are not going to be able to see the difference, not able to see the difference between the different components. For heterogeneous mixture, it's easy to see the difference between the components with the exception of the colloids, and you already learned about the Tyndall effect. So in a homogeneous mixtures, you have liquid solutions, you have alloys, okay, is when you have a mixture of different solids that they are melted, mixed together, no chemical combination, and then you have a mixture in there. And then you have gas solutions. In one example of gas solutions is the air. Okay, now in heterogeneous mixture, you have suspensions, the colloids, and the mechanical mixtures. On the other video, I was explaining that is when you have a mixture, your salad bowl is a heterogeneous mixture and an example of a mechanical mixture because you have all solid ingredients in there, you're able to spot them easily. Also, when you have vinegar and oil, since they are immiscible means non soluble liquids, you are able to see the difference clearly in there. That's another example of a mechanical mixture in which the components, they are liquid. Your first step when you're separating a mixture is just to classify that. Once that you classify your mixture, then you can proceed to select the appropriate technique, and then you have to analyze the physical property that you're going to use. For example, for homogeneous mixtures, you have only 4 different techniques: evaporation, distillation, crystallization, and chromatography. When are you going to use evaporation? When you want to recover the solid in that solution, and that solid is an ionic compound. What is an ionic compound? And a compound that is made of a metal and a non-metal. So for example, when you have salt dissolved in water, that's the chemical formula for salt. You're gonna be able to recover the salt by evaporation. Why? Because when you are boiling the water, the forces keeping the sodium and chlorine together is, the heat that is absorbed by the mixture is not enough to break that ionic bonding. That's why you're gonna be able to recover the salt in a solid stage. The physical property used in that technique is the boiling point. And usually you're gonna have an evaporation. See, evaporation dish exposed to a sort of heat. The mixture is gonna absorb that heat, the water is gonna evaporate, and you're gonna be able to recover the solid. When do you use distillation instead of evaporation? You use distillation when the substance that you want to separate, the boiling points, they are far away. See, boiling point is the difference in the boiling point is big. For example, alcohol is going to evaporate at standard room and temperature. So if you have a mixture of alcohol and water, you can use distillation because alcohol is going to evaporate faster. And the difference between the boiling point of water and alcohol is big. That's when you're going to use distillation. Okay, also, you can use distillation to separate the water from the salt when you want to recover the water. See, the water from the salt when you want to recover the water. See that? How that's gonna work? Simple. Remember, the property that you're using for distillation is the boiling point, and over here you have an example of a distillation apparatus. So you have a flask over here with your solution. You're gonna input a sort of heat. The substance with the lowest boiling point is gonna evaporate, go through the condenser over here, that then is gonna condense in the beaker because you're gonna be passing water that is not gonna be in contact. See, you're gonna have a transfer of heat here. You have a vapor going through the condenser, and in the condenser, the function of the condenser is to condensate that vapor. Okay, that's how distillation is working. Let's say that you want to separate alcohol from water. The alcohol is going to evaporate faster. Once the vapor goes through the condenser, cold water is going to be absorbing the heat, condensing the alcohol that is going to be recovered on the beaker. Another technique that we have over here to separate solution of homogeneous mixtures, crystallization. Okay, remember evaporation when you want to recover the solid, but the solid is an ionic compound. Crystallization is when you want to recover the solid, but now the solute is a covalent compound. An example of a covalent compound is sugar. What is the physical property that is used in that technique? The state of matter. Because you're gonna heat, it's a combination. Crystallization is a combination of evaporation and a disruption of a state of matter. Because you're gonna be evaporating the liquid until you have a saturated solution. And then you're gonna introduce like a tiny amount of the solid that you want to recover, and you're gonna disrupt the equilibrium between the solid and the liquid stage, and then you're gonna be able to see all the solid coming out of the mixture. Okay, that's how we make sugar in real life. Those factories that they're making sugar, they use crystallization. They have big vats that they use to evaporate all the water, and then when they have a saturated solution of sugar and water, they disrupt the phases, the liquid and solid phase, and they're able to recover the sugar in the solid state, the crystals of sugar. That's what is called crystallization. Another technique that we have to separate mixtures that are homogeneous, chromatography. Okay, chromatography is using solubility, but not only solubility, it's the rate of dissolution, because you're gonna be able to separate different components in a solution by looking at the dissolution rate. Okay, the different components in that mixture, they are gonna dissolve in a solvent that you're gonna use at different rate, and then you're gonna be able to see the different components in there. One more time, just remember that when you are separating mixture, your first step is to classify the mixture. We already discussed different techniques that we can use to separate solution or homogeneous mixtures. Now we're gonna discuss the different techniques that we can use to separate heterogeneous mixture. Now, remember, your first step is to classify. And once that you classify your mixture in the heterogeneous mixture, you have 3 subgroups in there. Let's say that you have a suspension. You already know what is a suspension. You have particles that are going to be dissolved, but then you have particles that are so big that when the mixture is left undisturbed, the particles, they are going to settle at the bottom. In one example is coffee. When you're making coffee, you put in the coffee grounds, you leave that there undisturbed, and the solids, they're going to deposit at the bottom. There are two ways to separate that type of mixture, okay? You can use decanting. You remember on decanting, the property that you use it is density, because you are removing the solid that you have on top, no, the liquid that you have on top from the solid that has been deposited at the bottom. The physical property that you're using over there is density, because the solid is more dense, so it's gonna settle. But let's say that you want to use filtration. When you're using filtration, the physical property that you're using is particle size. Why? Because you are making sure by using filtration that all the solid that you have in your mixture is retained in the filter paper, okay? Using them particle size as the physical property to separate the different components. So suspension, one more time, you have the technique that you can use depending on what you want to recover. The decanting, if you don't need, the only thing that you need is to separate the liquid from the solid, but you don't need the liquid to be free of solids. Filtration, when you don't want any solid on that liquid, you're going to use filtration. The solid particles, which are bigger, they're going to stay there, retained in the filter paper. Now, let's say that you have a mechanical mixture. A mechanical mixture, it could be solid. When you have beans of different colors, remember that I was showing you that in class, okay? You can use the color to separate them, which is a physical property. You can use texture. And think about the salad bowl. When you have lettuce, and you have tomatoes, and you have cucumbers, and you have onions, but you don't like onions, how you gonna separate that? You're using the color, but also you're using the texture as well. When you're separating the onions, let's say that you were putting over there raisins, and you know that when you're touching the raisins, the texture is different to the one of the tomatoes, okay? So for mechanical mixtures, hand separation. If for hand separation, you're using color and textures as the physical properties. In mechanical mixtures that involve solids in there, you can use hand separation. When is practical to use that, because let's say that you have a mechanical mixture that is made of rice, salt, and iron fillings. Okay, let's say that you have that mechanical mixture made of these three components. Are you gonna be using hand separation? You can use hand separation to separate the rice from the salt, but it's gonna take a long time. It's gonna take you a long time to separate the rice of the salt. If you have small pieces of items, even more time to separate that. So in that case, you have a mechanical mixture, but hand separation is not practical. What is the technique that you're going to use? Sifting. Sifting is also using particle size. Particle size as the physical property. In this particular case that I'm showing you over here, you can use a combination. Sifting to separate the salt from the rice and the iron. But let's say that you have still a small particle of iron in your salt, then you can separate the iron using magnetism, which is another technique. But you're going to use magnetism when one of the substances involved is magnetic. Okay, so one more time, for mechanical mixtures that are solid, you have hand separation when the size of the particle is so big that it makes the technique practical to apply. But you're gonna use sifting if the size of the particle is small. Okay, size of the particles, they are small, and it's very difficult to separate that by hand. Another technique that you can use to separate mechanical mixtures that involve liquids is extraction. Okay, extraction involving liquids. especially liquids that are immiscible. Liquids that are immiscible in there. See? When the liquids they are immiscible, you're gonna be able to use extraction, but you're gonna be able to see the difference between one example is the vinegar and the oil. You're gonna be able to see the difference. You know that the oil is gonna float on the vinegar, and the consequently density is the physical property that is used in extraction. If you can have 3 or 4 liquids there that they are immiscible and that they have different densities. See, if they have similar densities, you are not going to be able to use extraction. The catch here in extraction is the difference in density. See, it has to be significant for you to use extraction to separate the different liquids that are involved. And for colloids, you have a technique that is called centrifugation. Remember, colloids, example, the colloids, we have milk and then we have blood, okay? Blood. Meal, when you look at the meal, see, you don't see the difference between the components, but still we have particles that they are not dissolved, but they are small enough that they will not settle. How we are gonna separate the fat from the milk? Using centrifugation. Centrifugation, I don't know if you have seen a centrifuge. It's a machine that is going to move in circular way super fast, okay, just to make sure that all the solids that you have in your colloid, they deposit at the bottom. The same happen with the blood. When you're going to the doctor and the doctor is ordering you blood work, when you go to the lab court, or you go Quest lab, then they are taking your blood, they are putting that in a small test tube. Those test tubes, they are put inside a centrifuge. The centrifuge is rotating quickly, see, a high angular velocity, so the plasma is recovered at the top while the red blood cells are recovered at the bottom, okay? At the bottom. And in this case, for centrifugation, density is the physical property that is used to separate, because after applying that centripetal force, the substance that is less dense is gonna float, while the substance that is more dense is gonna settle at the bottom. You're gonna be able to recover both components in there. This is everything that you need to learn about the separation of mixtures, and I think that with all this information, you're gonna be able to complete your classwork. One more time, this is a summary. Remember that when you're separating mixture, your first step is to identify the mixture. So you have to ask yourself, do I have a solution or do I have a heterogeneous mixture? If you have a solution, you have to ask yourself, what do I want to recover, the solute or the solvent? And then you will ask one more time yourself, is the solute a solid? Is the solute an ionic compound or a covalent compound? And based on that, you select your technique. For heterogeneous mixture, you have then to classify your mixture in the different subgroups. Do I have a suspension? What do I have at the end? Do I have a mechanical mixture? Is the mechanical mixture solid or liquid? Do I have a colloid? Okay, what is the only technique that I can use to separate a colloid? That's the process that I want you to get familiar with, because when you are questioning yourself about what you have, then you're applying your critical thinking skills.